Let's talk about some open source OWASP tools to help out with penetration testing coverage. A little bit about me. My name is Ken Prohl. I wear two hats. I'm the CTO for CodeDX. CodeDX is a system or platform that allows you to bring in all of your application security testing activities, so static, dynamic, IS, manual, bring that all into a single platform. You can correlate and deduplicate and manage all the findings. So we have a booth here at LastCon. Feel free to stop by and learn some more about that. I'm also the principal investigator for Secure Decisions. Secure Decisions does cyber R&D for the government, and actually CodeDX was initially funded through funding from the government. So the Department of Homeland Security had small business innovation research contracts where CodeDX kind of started out, and then we eventually spun that out into a separate company. The tools I'll be talking about today are also sponsored by DHS, and I am the project leader for both of those. It's called Code Pulse and the Attack Surface Detector. My background is initially in software development. I was doing C++ development for custom software, actually for the parent company, which is Applied Visions. And about in 2000, I started working under the Secure Decisions division, doing cybersecurity research, a lot of in the network side of things, particularly in visualization, how to make sense of all the data that's being collected. And a lot of that stuff you'll see as part of the presentation today. It's all about like how can you make this stuff more usable and consumable. All right. So a little bit about the agenda. I'm going to start out just giving you a brief overview of the two tools. We'll talk about the white hat penetration tester, what advantages they can have and how we can sort of make things a little bit better for them. The typical workflow for a penetration tester, and the importance of understanding the attack surface and how that fits in. Then we'll talk about both of the tools, OWASP Code Pulse and the OWASP Attack Surface Detector, what's their challenges that they address, how it works, and a short demo for each of those. And then finally wrap up with just some pointers to where you can find some more information and some Q&A. In the end, I hope that you learn and see how we can make black box penetration testing less opaque. All right, so the two tools I'm going to talk about today are OWASP Code Pulse and the Attack Surface Detector. I've been to many different talks, and a lot of times there's projects that are kind of not really released yet or they're up and coming. These are both mature projects. Code Pulse is a lab level project within OWASP. It's been around for about 4 years. We've recently done a lot more features to it, and I'll go over that today. It's a way of being able to see what kind of code coverage you're getting during your testing activities in real time. The Attack Surface Detector is also an OWASP project. It was recently made an OWASP project. This builds off some of the work that Denim Group has done in the past. We actually collaborated with them on this research project, and Secure Decisions has continued to evolve the Attack Surface Detector and add additional features, which I'll talk about today. The overall objective of the Attack Surface Detector is to figure out the attack surface and use that to feed into existing tools like ZAP and BERT. So is anyone here considering themselves a white hat pen tester or white hat pen tester? Is anyone? Or someone in the back? Very cool. Also, ethical hackers and OWASP terms, the breakers, people that are trying to break into applications as opposed to builders. You have plenty of disadvantages over malicious counterparts. Attackers have all the time in the world, and they just need to find one vulnerability, where a white hat pen tester, they need to try and find all of the vulnerabilities and protect against it, and they don't have as much time. And if you're working with a development team, they're going really fast. DevOps, they're putting out releases faster and faster every day. So how do you keep up with that? It's a big challenge for penetration testers. So there's a few advantages that can be leveraged. So if you have access to the server binaries or bytecode, and if you have access to the source code, there are some additional capabilities and improvements and efficiencies that can be made with access to those. And even if you don't have access to that, I'll talk about some other approaches that can be used where you can still make use of some of these capabilities. Anyone have used OWASP ZAP before? Right, cool. So ZAP is a freely available tool from OWASP. It's a flagship project. It allows you to both manually or automated testing against a web application. About Burp. Awesome. Burp is a commercial tool. I think there's a community version, also a low-cost professional version. Both really, really great tools, and we'll be using these tools in the demonstrations today. But what I'm going to talk about also applies to just doing manual testing, or if you're using commercial tools like NetSparker or Acunetics, or if you're doing Selenium testing or just QA testing in general, how can you see how much coverage you're getting? So let's go over the typical penetration testing workflow. You have this web application here, probably connects to some data repository. Typically, a penetration tester will try and figure out the different user roles to authenticate, right? So if you can't authenticate to the web app, you're probably not going to be able to test much of it. You need to either be provided or figure out how to get into different parts of the application. And then go through endpoint enumeration. A lot of times you'll kind of just go through the application, go through every link that you could find, fill out the forms, see if there's multiple stage processings that happen, like if there's a checkout process, you have to first fill out a form and you go into the next page. Kind of go through the application and exercise it and figure out all the different entry points and different points that you can go from there. And then a lot of times you'll use automated spider or crawler, so burp and zap. You can, once you have this kind of go through the manual process, then you can run these tools and they'll automatically kind of discover all of the different URLs that they can see. And then you can also do brute forcing or forced browsing. So there may be things that the dynamic tools can't see from the outside. So they can use like dictionaries to try and guess at other URLs that there might be. Like let's try to put /admin on this URL and see if we can get in. Because anything that's unlinked, from the outside you really can't discover unless you try and guess or just get lucky. From the endpoint enumeration out pops the attack surface. The attack surface is all of the entry points into the application. What are the URLs that this application is exposing? What parameters is it expecting? And we'll talk more about the attack surface in a bit. And then once you have that, then you can go about the vulnerability discovery process, whether it's doing passive, active, or fuzzy. So let's talk about the attack surface. Let's use a home as an analogy. So for home, if you're worried about an intruder, what are the different ways that someone can get into the house? Well, they can check the front door, maybe that's unlocked, and they can just walk right in the front door. Or maybe there's a side door that's available for entry. Or maybe there's an open window to get into the house. The same thing for an application. For an application, you have different ways of getting in. So maybe there's a login page that you have to get into, or there's other points or other entry points to get into a web application. So let's take a look at kind of the internals of a house, look at the blueprint of it, have that open window, but that's just kind of the starting point for getting in, right? So you need to know, what are you trying to protect and where is that? So you have to go from that open window to the sensitive information that you're trying to protect. The same thing with a web application. There's different paths that you can take through the web application to get at that sensitive information. But a web app isn't that simple. It's more like this. It's more like a skyscraper, right? It's much more complex. And it's not just a simple blueprint, but you probably have something more like this, or many floors that you have to go through. So looking at something like this, how can you figure out how much coverage you're getting for an application of this size, right? It's just massive. How do you keep track of that as you're going through the app? So that's why we created Code Pulse. So if you look on Wikipedia at the web application security scanner entry, you'll see this in there, and it wasn't put in by me. The penetration tester should look at the coverage of the web application or of its attack surface to know if the tool was configured correctly or is able to understand the web application. So that's a really important part in running these tools. And if you're running dynamic tool, it can tell you all of the endpoints that it sees, but it doesn't know what it doesn't know, right? So how can you measure that? So Code Pulse was designed to meet these challenges. When you're doing your testing, manual, automated, how much of the application did you actually cover? Did you reach all of the app? What percentage? For the actions just performed, which part of the source code were executed. So as you're playing with the app, as you're trying to get to different areas, or like we're looking at the house scenario, as you're putting in different input, what are the different ways you can go, and how can you see this? How can you see how your input is affecting the execution of the code? Which tools are getting better coverage? So you try Zap, you try Burp, maybe you're evaluating commercial tools. Which ones are giving you better coverage, or combinations of coverage? Which testers are giving better coverage? So if you hire some outside pen testing organization, how much coverage, how much testing did they actually do? Or you have an internal team and you want to see how well from a coverage perspective they're getting, you can use this tool. How can you tune the tool to get better test coverage? So each of these tools have a lot of different attributes, a lot of different properties to get better results. This can be used to help improve that and get better coverage. And then finally, communicating the testing coverage to others. So you did your tests. How well did you do? So help with coverage gaps, help with tuning the tools, and help with communicating the results. So Code Pulse is a code coverage tool. Now you probably have seen other code coverage tools before. I think what you see in a lot of the other tools is you do your testing and then you get a code coverage report at the end. Code Pulse is a little different. Code Pulse is built for penetration testing activities. So it's kind of geared toward that. And it's in real time, which I haven't really seen any other tool that is in real time providing feedback as you're testing. And it's very visual. So the old adage that a picture's worth 1,000 words is very true. And my background is in information visualization. So if we can provide a picture that can portray information in a visual way, that goes a long way in communicating the results to others. It's also very scalable. So we have an application that's 2 million lines of code. I can show the code coverage on a single window of the whole app. It can really scale. So in a nutshell, Code Pulse is a real-time code coverage visualization tool for penetration testing activities. How it works, so we have the pen tester working with an application. In this case, it's WebGoat. Typically, it's a black box perspective. They don't know the internals of the application. But with Code Pulse, you install an agent within the application. So if people are familiar with IaaS technology, it's a very similar concept. We support Java and .NET, so you install this agent in your application, and then with that agent, we can keep track of all the testing activity that's going on and provide a real-time code coverage information back to the penetration tester. We call this glass box testing, because now you'll be able to see the inside of the application as you're testing, so it's no longer a black box. So it provides transparency, so you can see a lot more information, instant feedback, and again, helping with tuning your testing activities. So this is Code Pulse. This is what is called a tree map. Each of these boxes represent a method within this application, and it's sized by how big that method is. And so as you interact with the application, the boxes will light up to indicate that you've hit that method. And so just like the blueprint of the house that we saw, the floor plan, this is kind of a blueprint for the application, the makeup of the application. All of the classes and methods that make up the application, and you can see in real time how much coverage you're getting. So looking at some coverage scenarios, in this case, I took WebGoats, an OWASP project. I installed our Code Pulse agent in it, and I did some testing. So I used OWASP Zap in this case. So the thing that I did with this is I just started up Zap. I pointed it at WebGoat. I did a spider and an active scan. And this is WebGoat. This is all of the classes, and it's broken down by the namespaces. So you see like the SQL injection classes that they have. Some of it's cut off a little bit, but up here, one of the boxes was hit, which is the index.jsp. Also covered the login.jsp and the login controller class. So if I didn't, for my testing, I did everything. I gave Zap the URL WebGoat. I let it spider. I let it scan. But really, I didn't cover really much of the app. I only covered the login page. But by looking at this picture, I would be able to quickly see the fact that I didn't really cover much of the app. So then I took that a little bit further, and I said, okay, let me log in. So I logged in with the admin password. I ran the spider again, and I ran an active scan. And now, some more things were hit. I got a little bit more coverage in this case, and I can see that visually. And I thought, well, maybe I should try and navigate around WebGoat to try and let Zap know about some of the pages that it wasn't able to find. And then I got a much better picture. So you can see how this was able to help me tune my testing and overcome some of the things that I talked about earlier, where making sure that you have the login to get into different pages, and being able, going through the kind of that manual process where you're navigating through the application to get better coverage. So now, with this tool, I was able to use that to improve my testing coverage. And you can also see things that were still missed. So like this refresh DB screen is a method within WebGoat. I didn't go to that page where there's a page within WebGoat where you can, if you're admin, you can kind of refresh the whole database. I didn't cover that part of the application. I would be able to see that by interacting with this. So you can see here, these are the 3 scans that were done. I'm able to see visually how I was able to improve my testing coverage. So you can also use CodeDX to compare different types of testing that you're doing. So in this case, I'm looking at manual and automated. Everything that's in black was found by both techniques. It was found by both manual and automated scans. And the things that are in green were just found during my manual testing, and then the things in blue were found just by my automated testing. You can also use it to compare tools. So you can run one tool and then run another tool and see how much coverage you're getting between the different types of tools. Again, the black is overlap, the purple is tool B, and the green is tool A. Or compare testers. So you have 2 penetration testers that you want to see how much coverage they're getting. You can do that as well. Those are just kind of different scenarios that can be used. All right, let's jump into a demonstration. This is Contoso University, which is a sample application from Microsoft on how to build an ASP.NET MVC application. It's a kind of basic app where you have departments, courses, instructors, and students. You can add, delete, and edit. Yeah, so that's the app here. Close out. See. And so this is Code Pulse. In this case, I've given Code Pulse the DLLs and source code for the Contoso University application. It has generated this application inventory, which represents all of the kind of namespaces within the Contoso University app. We've also run dependency check against this application. We have that integrated. That's another OWASP project where it allows you to see vulnerable components that you might be using. For example, like using an old version of struts. This can be helpful for a penetration tester because these are different ways that you can get into an application, right? So if you know that this app is using a vulnerable version of a particular library, you can then try and exploit that vulnerability. So I can check off, I checked off the Contoso University namespace, and we see a bunch of boxes here that represent all the different methods. We see there's this migration class or namespace. These are all the methods within the migration namespace, which is probably never going to get called during runtime because it's just for updating the app. I didn't mention before, but Code Pulse and the Attack Surface Detector are integrated. So within Code Pulse, now we can determine the attack surface, and that's where you see these little icons here. So all these represent methods that are part of the attack surface. These are the entry points that an attacker can take to get into the application. So and that's in this controller's namespace. So I'm going to focus on the controllers, and we'll start up the agent. So in this case, it's again, it's a .NET application. I'm now instrumenting that. I'm going to attach it to this project. I'm going to start a new recording. And we'll just call this manual. So we're just going to do some manual exploration of the application. And all right, so I'll go to the home page, and IIS is just going to wake up. Again, it's now being instrumented. The first time it's a little bit slower. I can go to the departments. It should bring up a page where you can add and remove departments. Let's go to instructors, students, courses. So as I'm interacting with the app, you see that it's highlighting in real time all the methods that were touched. And I'm going to focus on the, so this box represents everything that's related to the courses. So this box here, all the methods within interacting with courses. So I'm going to go ahead and interact with courses, and you'll see how we're going to improve the coverage here, like this details and things like that. So we'll add a new course, course 100, it's the AppSec course, 3 credits, and it's in the computer science department. You see that we just hit some stuff here. We just did a create. I'm not a fan of calculus, so we'll delete that one. So now we've interfaced with that. We're going to head and let's edit the AppSec. It's a 4 credit class. We'll go ahead and look at the details of it. So I've exercised a lot of this, the courses, right? So I've got pretty good coverage here. But I missed a couple. I missed 2 boxes here. So one is this update course credit and update course credits with a parameter. So the Contoso University application actually has a hidden endpoint in it. It wasn't added by us, it's actually just in there. So it's not something that you can navigate to from the application. But if you go in, and if I go to like the edit here, so there's a hidden update course credit, which now I've hit that. What this endpoint does is it allows you to multiply every course by a certain number. So we're gonna multiply it by 2. And now I've received, now I've got full coverage. This update course credit, something that you wouldn't be able to see from the outside, but now having that inside perspective, you can improve the coverage. But we can take this a step further and look at one of the new features is to look at the line level coverage. And so if I'm looking at this edit method, takes in an integer, and it basically says, well, if that integer is null, go throw this error. Otherwise, try and find it. If it's null, throw another error. If it's found, then continue. So far, I've only gone through the happy scenario, and I got 5 of 7, so 71% coverage within this method. So we can go ahead and explore this more. I can go ahead and say, let's pass a nothing out through an error, which is expected, and you'll see that now we've covered that particular case and improved things. Or if I put in a ID that I know is not valid, now that's going to that condition. And now we actually have 100% coverage within this method. So before we're looking more at the method level coverage, now it's actually line level coverage. So you can go in and make sure you're getting complete coverage, and again, in real time, be able to see that. Yeah, let's do one more thing here. So I'm going to stop that recording, and we'll try and run zap against this. And I'll call this one zap. So now we're recording the interaction that Zap has with this web application. I'm going to go and spider. Now you see, as Zap is doing its thing, you can see all of the different methods that are being called, again, right in real time. And Zap finished its spider. I can stop that session. And now I can compare what Zap found versus what was found during our manual testing. And of course, the update source credits was not found by Zap because of not able to discover that hidden endpoint. So this is kind of a way of being able to improve your coverage and find things that you would otherwise miss. All right. So that was the Code Pulse part of it. Now I'm going to talk about the Attack Surface Detector. So, similar how we saw in the Code Pulse demo, there's parts of the attack surface that are going to be missing, unless you're doing, endpoint brute forcing. So we wanted to develop a solution that can provide a complete picture of the attack surface in an automated way. So the attack surface helps abbreviate pen testing efforts by automatically discovering the attack surface process. Particularly, it'll discover hidden or unlinked endpoints, just like we saw in the demo, and also optional parameters. So you may have like a debug parameter or other parameters that aren't going to be able to be seen from the outside. This can be used to precede tools like Zap and Burp. So by precede, it means feed those tools with the attack surface before you go on and do your spidering or active scanning, so it can discover things that it would otherwise be very hard for it to do. You could also compare the differences between applications, so you can focus your testing activities on what has changed between one app and another. So how does it work? So it performs static source code analysis. So you need to provide the attack surface detector with your source code, and then it looks at the different routes and the parameters for the different frameworks. So these are the frameworks that we currently support, the languages and frameworks, so C#, Java, Python, and Ruby, and these are all the frameworks underneath there that we currently support. We're looking to add more, and so all open source. So we're looking for contributions from others as well. So in summary on the kind of the benefits of it, I'll take questions right at the end. Yeah. Kind of the benefits, it minimizes the attack surface gaps. So you can find those unlinked endpoints. Also helps with parameter detection. So optional parameters that might be missing, or just knowing the parameter data type and the values that are expecting can improve your testing activity, right? So rather than guessing at the type of parameter, you now know that information, and that can be used. Precede, tools like Zap and Burp to make the testing process more efficient and help reduce time. So rather than having to manually enumerate the attack surface, either going brute force, or if you had access to the source code, you'd have to go through the source code and try and figure out what the attack surface is. And that can be error prone, and it's a manual process. And also be able to compare the differences between two applications to help target your testing. As we talked about before, trying to keep up with the fast pace of development. So these, we do have plugins for Zap and Burp. They're available right from within the tools. You can just go ahead and look for the Attack Surface Detector and install those plugins. And I'll show you how it works. So in this case, I'm going to use Burp Suite. And again, you can go here. You can either go, download it from our GitHub page. You can add it, or you can go to the BApp store and find the Attack Surface Detector, and it'll be all integrated within Zap or Burp. You would then see a new tab called the Attack Surface Detector. And then in the options, you can specify the source code location. This could be a folder, a zip file, a WAR file. If you have something that you want to compare it to, so in this case, I'm comparing version 2 with version 1. That's kind of the core that you need. And you could also put in the target configuration. So from the source code perspective, we don't know where it's hosted. If you fill this information out, then we can use that to seed Burp to know how to then go ahead and do spidering and attack. So once that's in there, you just click this import endpoints from source. It's going through the source code, figuring out all of the endpoints that it's able to find, and then you see those listed here. So these are all the endpoints. Again, I'm using the Contoso University application. We did make some modifications to show the differences between two versions of it. But here we see the number of detected endpoints, whether it's a get method or a post method, and whether it's been modified between the two different versions. And then you can click here and get more information. So you can see, for this create endpoint, this debug string was an added parameter since the last time you did your testing. This particular one, the integer changed to a string. This is a new endpoint that was added, so you can kind of get a sense for what has changed between different versions. And then within the target here, I'm just going to show all. So now this can be used right within the target of burp. These are all the endpoints that were detected by the attack surface detector. I can sort by comment here. So this is new endpoints that were detected, modified, and just endpoints that were detected via the attack surface analysis. And from here, you can use the standard burp tools, intruder, repeater, and the sitemap here is also pre-populated with all of the information that was able to discover. So that's kind of an overview of the attack surface detector plugins. Let's see what else we got here. And so for Contoso University, this is before pre-seeding, where I ran burp against the application, and then after pre-seeding, again, it was able to find that hidden endpoint, the update course credits. It's also able to find the delete and edit in the departments. In this case, it wasn't able to define that because when I ran this, there weren't any departments created, and so burp wasn't able to find that there was the delete and edit because there was no data in there to make that happen. But by doing the attack surface detector, you would be able to know about those other entry points into the application. And this is a report that burp can generate. Again, this is before seeding and after pre-seeding. So you can see that we were able to get a lot more coverage. We found more dynamic URLs, more static URLs, more parameters. So it's just a way of improving and demonstrating how you can improve the attack surface. Then within Code Pulse, we brought both in. So without the attack surface detector and with the attack surface detector, you can see that we were able to find things, a lot more boxes were highlighted here by first using the attack surface detector before going through the automated scanning. So in fact, there was, if you look at the controller's namespace, without the attack surface detector, we had 46% coverage. Then when we first ran that, we got 75% coverage, so increased it by 29%. This is a report from a commercial application that we tested. This was just running burp directly. This is just running the attack surface detector. And then this is running the attack surface detector and then running burp's automated crawling and scanning, which has the best coverage. But you can see how things have been able to improve on this commercial application rather than just the Contoso University demo. And then lastly, we have a command line interface for the attack surface detector. So one of the challenges is you may not always be able to get access directly to the source code. So if you're doing a scan or a review for someone else, they can run this attack surface detector CLI tool, which will output a JSON file of the attack surface and then give that back to the tester that can then be imported into Zap and Burp or use it for other purposes as well. So without having direct access to the source code, which is sometimes sensitive, sometimes especially for black box testing, this is a way of being able to still use these technologies without having direct access to the source code. And that's a wrap. So here's where you can learn more about the tools, the Code Pulse. We have code-pulse.com website. It's also on OWASP. I have some flyers here on both technologies. Zap that we used here, it's also an OWASP project, WebGoat. Dependency check, you can find all those in the OWASP repository. And the Kotosa University demonstration is available here, and then a burp suite, which I used. So thank you, everyone. Appreciate it. We'll take some questions. Yes, sir.
So you said that your attack surface was part of the code. Yes. Is it also sold?
This is nothing is sold here. This is all open source, freely available. The attack surface detector can be used independently, either using that CLI, where you just point it at your app, you get a JSON file of the attack surface, or you can use it integrated with burp and zap plugins. Or if you get Code Pulse, it will have this already embedded inside of it, and then you get the nice addition of being able to see with that tree map all of the things that are part of the attack surface are highlighted based on the same kind of analysis that's done. Yes?
How does the attack surface detector work okay with single-page apps?
Yeah, so from my understanding, the single-page apps will, so like you have a Java, everything's kind of JavaScript-y, and, but they're still querying out to some back-end REST API, and that's where you can still figure out your attack surface, right? So so I think it still comes into play. Yes?
What if the API isn't per se REST, but uses WebSockets or something like that, where it's not actually doing posts and gets, but just using an established connection to constantly make requests?
Yeah. That's a good question. Yeah, there's other parts of the attack surface besides just web requests. That's not currently covered, but that's a good potential area for expansion.
Will your slides be available on website?
Yeah, I will post them. Yeah, absolutely. Yeah. And I'm at the CodeDX booth. I can provide a more in-depth demonstration. Really looking for feedback. Again, it's all open source. We're active. Feel free to reach out to me if you want a demo. We can set up a time to do a demo. If you're looking to contribute or if you're looking to just use it. Really interested in getting feedback from the community. So feel free to reach out. All right. Thank you, everyone.